we made this project about stellar evolution.
We're going to tell you how a star is born and how it dies.
First, we gotta start somewhere, and that is with the molecular cloud. So, before a star is a star, it starts forming a bunch of gas and dust, and that dust is the molecular cloud.
They are very cold, so atoms start to bind together. The dust and gas particles become very dense, and stars start to form. This here is a protostar.
These are formed after a clump of dust and gas breaks off of the molecular cloud. Angular momentum turns the clump into a rotating disk. The pressure and temperature begin to rise, and thus making the protostar.
Then, the temperature continues to rise, and everything begins to become more dense. Once the protostar reaches 15 million Kelvin, it can become either a low-mass star or a massive star. Then it becomes a main sequence star, just kind of doing its thing for millions or billions of years.
Let's say it becomes a low-mass star, which contains less mass and taking billions of years, and the star starts to run out of hydrogen and moves what's left to the outer shell and begins to fuse it.
The low-mass star expands into a red giant, one of the stages to its death. Then the red giant starts to eject its outer layers, gas and dust and stuff, which can cause explosions. That's a... Did we get the part of
nova? Anyway, after the explosions, what remains is a planetary nebula. The small, dense core of the star is exposed while the gas floats around it. The red giant is dead now.
The small core of the star is called a white dwarf. It's not nearly as hot as a red giant, and it no longer creates energy by fusion.
Once the white dwarf completely cools down, the light leaves it, and it becomes a black dwarf, which is the end of the low-mass star.
Onto the other path. If the protostar does not turn into a low-mass star, it may expand further into a massive star.
It's a very similar process to the red giant. However, it expands a lot more
into a red supergiant. Like a red giant, hydrogen fusion eventually stops, but instead of a nova, it becomes supernova. It is a much larger explosion than a nova and collapses the inner core of the star.
Which can lead to two different things: a neutron star or a black hole. If it becomes a neutron star, the white dwarf collapses to about 10 kilometers and becomes extremely dense.
They spin very rapidly, are incredibly hot, and are very magnetic.
Neutron stars emit high energy beams toward the north and south poles. While the neutron star is spinning, if the beams point towards Earth, they appear to pulse. So this is a pulsar.
They spin super fast and slow down as they age.
So let's get back to the supernova. If the supernova did not become a neutron star, it can only become a black hole. Only large mass stars can become and create black holes.
Basically what happens is the star cannot withstand its own gravity, and after the supernova, a black hole remains. Gravity wins, and it leaves behind an actual black mass of nothingness, which is the very last step in a massive star's life cycle.
Yeah. This is the molecular cloud. Excuse me.
Goes like that. We'll just cut that out.
Once the protostar reaches 15 million Kelvin,
No.
Kelvin. 15 million Kelvins. I'm taking billions of years.
This is a mess. believe. What?
Just getting into it, dude. You ruin everything.
You so dwarf. Gravity wins and it leaves behind an actual black mass of nothingness.